Hello friends, I know it's been a really long time since I've done a video. In fact, I think the last video was of the Arduino hovercraft. I've been working on some projects for some customers that have been a little bit more complicated, but I have missed the videos and I hope to do more soon. Today I'm pretty excited. I think this will be a fun one. I've got this stepper motor that I'll be controlling via Bluetooth using a smartphone. I've wanted to do a Bluetooth Arduino application for quite some time. So I bought this gear motor and this Bluno Nano BLE from Robot Shop. The Bluno Nano is basically an Arduino Uno with built-in Bluetooth Low Energy or BLE. Connected to the Arduino, I have an L298N motor control board, which is capable of controlling both speed and direction of the motor. I've used this board in many of my other videos. It's one of my favorites, and if you're not familiar with it, I would encourage you to check out some of my other videos. The motor I'm using has a built-in encoder, so the idea here will be that I will control the speed and direction of the motor using my smartphone, and then I'll have the Arduino calculate the RPM of the motor and feed that back to my smartphone as well. I'll first explain the Arduino code, and then I will show you how I built the app for my smartphone. First of all, we have to initialize two of the pins on the Arduino, pins 9 and 10, which will be the clockwise and counterclockwise pins that connect to in1 and in2 on the motor control board. We have an integer PWM that will be for controlling the motor speed, and one called direction, DIR, that will control the motor direction. As we will be receiving Bluetooth commands from the Android app, we will need a string variable to hold those commands. And we'll have a long integer that will keep track of the last time we sent information from the Arduino back to the Android app. The integer count will be used to count the pulses of the motor encoder, and the long integer rotation time will be used to time how long it takes for the motor to complete one full rotation, and using that information we will calculate the RPM, which we will do a float. Here in the setup we will initialize our serial communication as well as initialize our clockwise and counterclockwise pins as outputs, and we will set those to 0 so that the motor doesn't spin when we first boot up the Arduino. We're going to use pin 2 on the Arduino as an interrupt, and what it's going to do is run a code each time that it detects a pulse from the motor encoder. We will then initialize our display times and rotation times. Here in the loop we will search for a command from Bluetooth, and if we find one we will store it in the variable command. Now if command happens to be an A, we will set our direction to 0, which means we will go forward. If the command is a B, we will set our direction to 1, which means we will go in reverse. And if the command starts with C, this character at position 0 is looking for the first character in the string. If that happens to be a C, we're going to strip that C from the command, and the remaining numbers will be stored as our PWM value. So if the string, for example, is C125, that will become 125. That 125 will be stored as our PWM value. With this little section of code, we will be sending via Bluetooth the RPM value to the Android application every 2 seconds. And down here, depending if we get a forward command or a reverse command, we will set the corresponding analog write pins to the PWM value. The particular gear motor that I'm using has an encoder that pulses 280 times per revolution. So each time Arduino pin 2 detects a pulse from the encoder, the variable count gets incremented by 1. And once the code has counted 280 pulses, it records the time values and calculates the RPM, which is then communicated back to the Android app. So that's it for the Arduino code, and like I said earlier, this board is treated the same as an Arduino Nano for when you upload the code. So let's move on to the Android application and show you how that works. For my Android app, I used MIT App Inventor, which, if you haven't used before, is definitely worth looking into. It's a very simple platform for developing Android applications. So I'm not going to go into great detail on how to use MIT App Inventor. There are already hundreds of tutorials out there for how to use this application. But if you know the basics about MIT App Inventor, you should be able to follow along. So the first thing I did was to insert a few of these horizontal arrangements, and then within each one I inserted a button and a label. So here I have a button here, and a label here, label here. I also added a slider down here that will control the PWM value, and then this is another label over here that will display the RPMs. Now, I've worked with Bluetooth before, but this is my first experience with BLE, or Bluetooth Low Energy, which I found is a little bit more complicated, but probably much more powerful. So in order to automatically connect to your Bluetooth device without having to query a list of available devices, you'll need to know the service UUID number as well as the characteristic UUID number and your device's name. Now, these service and characteristic numbers I had to look up online for the Bluetooth Nano, but this global name, my first Bluno, is what I named my device, and I will show you how to change the name of your device in a minute. So in order to set these variables, I simply went to variables here, initialize global, and you can change the name to whatever you want, and then just use a text box to join that. Now, depending on what type of smartphone you have, you may have to ask permission for this application to access Bluetooth Low Energy devices. So here I have when screen initializes, and I pulled that up through this screen one here. I have this call, ask for permission, android.hardware.bluetooth LE, which was needed for my phone in order to get it to work. And then this call Bluetooth Low Energy 1 start scanning. We'll start looking for the devices. Now, I forgot to mention that in order for this to work, you'll have to import the extension Bluetooth LE. So you'll have to click here on import extension and find the file path for that library. So once you have this Bluetooth LE extension added, you can pull up this block here when Bluetooth gets connected, and here we're simply changing the text on our buttons and labels to reflect that we have connected to our device. Once we've connected, we're going to pull up this Bluetooth register for strings, which is also under this Bluetooth LE menu here, and we're going to use our global variables for our service and characteristic numbers. And for me to get this work, I had to set this UTF to false. Similarly, if our app detects that our Bluetooth connection has been broken, it will change the button back to its original state of connected, and our label to show red, not connected. Okay, this block here corresponds to button 1, which is our connect block. And if the text on that block is indeed connect, then we're going to use our service UUID and our global name, which we defined earlier, to automatically connect to that device. Once we've connected, we don't need to scan for Bluetooth devices anymore. If our button is not set to connect, but is rather set to disconnect, then we will disconnect the Bluetooth device, and we will once again start scanning for available devices. Okay, button 2 over here is the button we will use to change the motor rotation direction. First of all, this little piece right here, if the Bluetooth is not even connected, it'll just ignore the clicks. But if it is connected and we want to change the direction, we can click that button, and depending on what state the button's in, it will either write a B or an A using this call Bluetooth write strings command. And that will send that command to the Arduino. Alright, slider 1 down here will be used to change the speed of the motor
Once again, we have this condition in here that will ignore the slider change position if the Bluetooth device is not connected. But if it is, we're going to write that new position to the Arduino. And before we do, we're going to add the letter C in front of the position. If you remember back in the Arduino code, we recognize the C command as giving us a new PWM value. This join command here is found right here in the text section. So if you remember, the Arduino will be sending a new RPM value to the Android app every 2 seconds. And once that Bluetooth string is received, we need to write that value to our label 3. Now when I first wrote my application, I didn't have these pink blocks here, but I was getting a bracket and quotation mark on either side of my RPM values. I'm not sure exactly why this is happening, but maybe if you know, you could leave a comment. I think it may have to do with these strings being pulled in as a list of strings rather than individual strings. Either way, by putting in these replace all text, replace the parentheses and brackets with a blank space, it was able to clean up my RPM value so it looks just nice. So that's it for the MIT app. We'll just run it and see what happens. Now really quickly, I did mention earlier that there was a way that you could change the name of your Bluetooth device, and this is how I found out how to do it. I went to this DF Robot site and clicked on the Bluno section, and it shows you how you can change your device settings using the serial monitor from the Arduino IDE by entering the AT mode of your device. So down here, different commands if you wanted to change, for example, your baud rate. But here we go. If you want to change the name of your device, you can use this AT plus name equals command and change your device to be whatever you want. And that way, when you write your application on your Android, you can have it auto connect using that name.
All right, let's test it out. I'm going to click the connect button. Looks like it found the Arduino just fine, and give it a little bit of speed here. Give it a chance for the RPMs to update. There they go, 58. We'll give it a little more speed. Now 96. Cut the speed back down. And let's switch the direction. Perfect, seems to be working great. Well, hopefully you found that video interesting and useful. If you have any questions, please leave those in the comments and I will try to get those as soon as I can. As I promised earlier, I do intend to make more videos coming up. I think one that I have in mind is linear actuator position control. And what I need to know from you guys is if you would rather have a video where I control it with an RC controller or with a Bluetooth app. So let me know, and once again, thanks for watching.